no, I know. Yeah. Hey, hi, everyone. So when you squeeze in a panel at the end of the day, right before cocktails, you make it really good.
Sure.
That's what we've done, and we make it short, which we'll also do. So I'm going to introduce everyone just to save time. So you didn't sit in the order. Yeah, I know. So Shridhar Pandey is Senior Product Manager of AWS Lambda, and that job and title speaks for itself. Sanjay Agrawal is at First American, Senior Director of AI ML and MLOps, specializes in enterprise architecture, cloud technologies, DevSecOps. And then we have Venkat Iyer from Talkdesk, VP and Global Head of Platform Products. And then we have Ilan Robinovitch, who used to be at Datadog and is currently taking some time off. And at Datadog, he was SVP of Product and Community, and also spent most of his days diving into container monitoring metrics.
Who doesn't take their vacation on a panel in San Francisco at a tech event? But no, this is a lot of fun. So.
Yeah. And this mix-up happened last year also. Ilan, you're not Indian, are you?
I am not.
Are you supposed to be on this panel?
No comment.
And Vikram leads engineering at Astronomer, Senior Vice President of Engineering. And I guess I should have introduced myself. I'm Salil Deshpande. I'm from Uncorrelated Ventures. I'm one of the investors in Sedai, thanks to Tim Galleri, who introduced the company to me, and also one of the seed investors in Astronomer, also thanks to Tim Galleri. So we had a little email debate on whether we should start broad and then get narrow, or start narrow and then go broad. And there was some disagreement about that. So finally, I had to use the powers vested in me as a moderator to decide to start narrow and then go broad. So my first question for the panelists is, what are some bad architectural ideas that would prevent an app from being autonomously managed? And let's start randomly. I don't really want to start with you because you're going to say
anything not on Lambda.
Anything not on Lambda, yeah.
Yeah. That would have been a good answer, by the way.
So can we? Do you want to start or?
Yeah, sure. So I think I was talking about this earlier as well. So one of the things we recommend, regardless of whether you're doing Lambda or containers or whatever, is this idea of codeful versus serviceful. So do not use function code to express state, like use state machine, right? And every time I think of it, there are other problems, but the first thing that comes to my mind is this would be a nightmare to operate, right? Every time something goes wrong, now you have to go look at code first, and it could very well be even if something happened between state transitions, you're going to have to look at code. So that is one that I can think of, without stressing myself too much. Where
do you put the state machines?
So you could use, in the serverless world, you could use step functions. That's literally what it is built for, right? And to tie that to some other principle is have the compute. You get this liberty in the serverless world where you could have a single purpose Lambda function, the smallest unit of compute that you can express, right? And a whole bunch of them are chained in whatever architecture, whatever design you prefer, using a bunch of state machines or connected through events and so on. And what that does is it makes it very granular to manage and automate or make it autonomous when you want it to be. Because in that case, if something goes wrong, you know the exact granular unit where it is wrong, or the model which is monitoring would have an idea and would find it much easier to get rid of it rather than or substitute it or fall back or whatever redundancy mechanism is built in, versus in a state where it's not as simple, where you have I don't want to say monolith, but there's an expression that folks use. I don't like it. They call them fat lambdas, where you've written a whole entire business logic which could be broken down into a series of steps. You have all of that dumped in one single place, and those are generally over time they don't scale very well.
Okay. Let's keep going. Let's make one round all the way through on this question. And if you if you have more than one idea, we can come back to the second one.
Sure, yeah. So I'm not going to go as deep as this gentleman went into lambdas. I know a little bit about lambdas, but I'm going to keep it a little bit generic. So one of the bad patterns that I've seen is when people devise systems, they don't think about what if the system fails, right? So autonomous systems have to have, like, example would be a full-scale driving, right? You drive Teslas and you have to be at the steering wheel. So just in case if something goes wrong, you can take control. You have to think about computer systems the same way, right? What if the model goes wrong? What if there is something that doesn't work? Do we empower the human beings to take over that part so that the system doesn't go down and can still keep functioning? Because I see a lot of risk associated with things going wrong, and we haven't reached that level of maturity yet where we can 100% trust the systems that will always ever perform the way they're intended to perform. We have bugs, right? We have all kinds of issues. So that's my answer, is that always think about an alternative when you're devising the autonomous systems, that if those systems fail, God forbid, how are you going to run your overall system?
So you're saying eventually Sedai is going to run over somebody on the street and drag them for half a block.
That's true.
The cruise car.
I mean, the one issue I'll take with that is I think most Tesla-related crashes are when the human decided that they knew better than the autonomous system and tried to turn the wheel. And I can say from firsthand experience, the only time I've ever been a Tesla that crashed is when I thought I knew better than the computer, and I was wrong. So look,
you were in a Tesla that crashed.
I may have crashed the Tesla, but it was not the Tesla's fault. It was mine because I thought I knew better. I think when you give autonomous systems very clear guardrails and you tell them they need to do one thing and one thing well, and you say, stay in the lane this way, they'll do that very well. If you tell that Tesla, figure out where the supermarket is, take me home, take me to the store, get me to work. You don't give it the addresses, you don't give it the cars around it, let it do all those things. Yeah, you're going to feel way too complex. But give it clear guardrails and it'll do the job very well.
Yeah, so my comment was not when the system is functioning, that's when you take over, but it's when the system fails for some reason, right?
I think the question is, do we know if it failed?
What do you do?
Yeah, I think the question is, do we know better than the system if it's succeeding or if it's failing when it's moving around? But I think you wanted to keep going, so I'll stop.
You've successfully way broadened the topic, but I wanted to make one round. I want to gather bad architectural ideas that would prevent an app from being autonomously managed.
So I think I'm in between of both of them. So I do agree. I think lack of monitoring, lack of telemetry, lack of compliance, security related areas. Okay, those data points, if those are not collected at the right time, can lead to the Tesla-like crashes.
Yeah, Ilan.
I won't sell monitoring, given that's what I did the last 10 years, and he just did it for me. I'll state the obvious one: building systems that can't possibly be automated through APIs or some other programmatic interface. I think while in general these days we've now hit a point in the world where even if you're on premise, there's likely an API to get compute, to get storage, to get a data store, to get whatever it might be. I still see teams make I don't want to call it the lazy decision, but like the quick, we'll get back to this later, we'll make an API later for it. How do you automate a thing that has no API to it?
Although these days you wrap all those things in other things
Sure,
that do have APIs.
Yeah, you know what the API is? It's create a ticket or have an alert fire off that wakes me up, and then I, as a human, implement that API by clicking the buttons. Like that's not an autonomous system. So I think by not having, I think that's one of the things is we automate, or sorry, we make a lot of things programmatic, and then there's usually like a corner case somewhere that's the one thing you can't do, and somebody still has to wake up and deal with. And I don't think everything should be automated, or everything needs to be automated. But if you want it to work autonomously, you have to have an API to it.
So I think it's actually very similar to what Ilan said, but I would generalize it to say, don't make a decision in code if you expect it to be automated. I think the core premise is that if you want something to be autonomous, you need to be able to say what decision is it actually going to make, be able to actually have some level of observability, whether you report on metrics or something like that, be able to have an eye to incoming traffic to say, I want to override this particular decision, and then be able to also track as you go forward what those decisions are basically being made over time, so that you can actually monitor, is this actually happening correctly or not? Because those decisions are going to actually be changing over a period of time. The second thing I would say is, when I say decision, I think the most common mistake I've seen people make is these decisions expressing them as being binary. And I think it's very rarely binary. When you actually are trying to make a system autonomous, typically there's a probabilistic element to it, which is at a certain point of time, you'd want to say, hey, I want to scale up. When do you want to scale up? That actually decision, if it's purely binary, it's very difficult to do. Where it's more often than not, you'd actually want to say, hey, based on the criteria which I want to establish over a period of time, then I'd want to scale it up sooner rather than later, versus actually I don't want to scale it up for cost reasons, as somebody else kind of brought up those kind of trade-offs. So I think it's the core thing I would say is decisions in code is the bad part. And then actually making a decision binary is also a bad part. And when you actually say, hey, everything is an API for an input and basically a metric to be sent out as an output.
Vikram, since you're from Astronomer, I wanted to ask you the typical workloads. I think everyone knows that Astronomer is the commercial entity behind the Apache Airflow project. The types of workloads that Airflow handles are these, data movement, orchestration type workloads. Those are not easy to make autonomous, right? So wouldn't that be one answer?
So they are not easy to make autonomous, primarily for two reasons. One, which is most autonomous systems in general, most scheduling systems in general, including the Linux scheduler, is based on preemptive scheduling, i.e. you can actually interrupt something. Data movement systems, even though we try to say there should be idempotent, they should be restartable, don't actually in reality always map to that. So that is actually one element wherein we say, hey, look, if your tasks are small and they're idempotent, yes, we can actually do that. But every once in a while, we run into people who say, hey, I can't actually do that. And those examples are basically when we struggle with making those autonomous.
Does that go back to what we were saying, what I was trying to say earlier, which is basically like, if you're make small decisions autonomous, make clear, guardrails autonomous. So if you're saying, I think what you're saying is, if you have a job that takes 10 hours to do because it's all one step, you can't automate that. But if you have a bunch of small jobs that come together to make an output, you can automate each and every single one of those individually?
Yes, it is. And we can actually scale them up. We can restart them. We can say, hey, look, run this on a GPU versus basically a CPU and all that kind of stuff. But it is the concept there I've actually used a lot is like, micro pipelines rather than macro monolithic systems, which are much, much harder to make autonomous.
Well, I made a list as well, and maybe I'll read off a couple things. So some of the things you said were on my list, like lack of metrics or observability. But one thing none of you brought up, at least I don't think so, is stateful apps. if the app has any state at all, then to make it autonomous, you have to deal with the state, and that's complicated and possibly impossible to make autonomous. So does that mean that all apps should be stateless? Oh, I see Vikram vigorously shaking his head, so I should go to him.
I actually think you're in the classic definition of compute-based systems. Stateless apps are a lot easier to make autonomous. I think stateful apps actually can be autonomous. I mean, we've had database transactions for like decades now, and there's a whole notion of like, checkpointing and rollbacks and stuff like that. But it needs to be deliberate as opposed to accidental.
Well, you can't handle application state like you handle database state with all the checkpointing and all the extra stuff on it, right? Because otherwise, if you do that, then it's got a database inside it, and it's slow, and then you're managing a database inside the app.
Not necessarily, actually. I mean, a lot of data transformation systems have checkpoints, and you would actually revert back to a particular last known checkpoint. And it is not really, it is basically state, but you can actually kind of say, hey, at what point do I checkpoint this?
But then something like Sedai has to be aware of all of that and be able
Absolutely.
to go back to that
Yes.
checkpoint.
So I think
is
it is hard, but I think that's basically where there is many different incarnations of autonomous frameworks for different layers of the stack that we'd actually want to manage. That's all. I'm not actually saying about a particular implementation like Sedai for like autonomous computing at a certain layer in the stack. I'm talking about general autonomy as a principle applied for like computing.
And I cut off Ilan there.
I was just going to say the best app is one where you've made the state somebody else's problem. So, and that's not to say that you can't have any state, but if every part of your microservice architecture is managing its own state, the exact problem you mentioned, which is everything's a database. I don't, the best. Not saying SD onto the cloud providers, although I'm sure you would love to hear me say that. But whether it's push it to a database, push it to another system down, push it to another microservice downstream. Like have the state in as few places as you can, so you don't have to fight that problem. And then, I think to your point, if we can get those systems to return something via an API, via a response to give us ideas as to where it is in a transaction and can I take an action on it, then we can make that autonomous. But that means you have to have state systems that are well architected, well designed, expose the right information to us, which you will never be able to do if every single microservice is managing state.
So isn't the simple solution to just make state somebody else's problem and just use some data service like one of the many cloud data services to store your data and make everything you do stateless?
That's pretty much.
Sounds good to you.
Yeah. I mean, that's where I started, right? That don't worry about, expressing state as some don't go into building APIs just to get state and so on. Let services do it for you.
My next question is, who stayed up 2 nights in a row watching the Cricket World Cup like I did?
I feel singled out.
Okay, so to get a little bit broad, Sanjay said on our email thread that you guys might be being myopic because the nature of workloads is going to change completely in the future. I hope I'm summarizing what you tried to say. So do you want to say more about that?
Yeah, certainly. So I think it was discussed in the previous talks that the autonomous and the AI systems have been around forever, right? It's nothing new that we are witnessing, except for the big change that happened in the last 1 year or so. There was a step function change that happened. The systems are becoming much smarter. They are able to reason. So the reasoning part wasn't there in the AI systems. We had to train the models. And then based on the information that you provide to the model, it'll just carry out whatever you ask it to do. But now the models are unsupervised. So they can absorb world's data and they can do reasoning. And that's completely changes how we think about building enterprise systems. So I work for First American, and I spent all my career in the tech industry. I was at AWS, I was at Microsoft and Sun, and now I'm part of First American, and I'm seeing the way the business processes have been devised for the last 125 years. And I see the potential of change that can happen in a company like First American. And I'm not singling out First American, but pretty much every industry. So when you have to, and I think about like last time when you bought a house, I'm hoping that most of the people here have bought houses. Real estate is one of the most valued asset class. I don't know how many people know about it, but it is, if you take the bond market and the stock market combined, real estate is even bigger than that. It's about $227 trillion market. But it is so difficult to transact real estate, right? When you buy a house, it still takes 30 days. You can buy a stock at your fingertips. Why? Why can't we have this asset class, real estate, get transacted the way the stocks get transacted? And the reason for that is because of the way the process is run in these companies. When you open an escrow and there's a lot of processes that run behind the scenes, that will make sure that, do I have the right to transfer the property to you? Is the legal description of the property correct? There's so much of investigation, legal work that gets done, and humans do that work. So in an ideal world, if everything is automated, the business architecture of a company like First American or any company can potentially change dramatically.
I just assumed you were about to tell me that my house will now be on the blockchain, and then it will be very clear who owns it and who we give it to. But I mean, this is the amount of manual effort that goes into any sort of physical transaction in the world. I mean, cars don't take 30 days, but similar idea. Like you don't go to the car dealership, see a price, get the car. There's a whole bunch of human work that goes on in the middle, registration, negotiating with the whomever, all that stuff before you get to do a thing. And we can automate the physical world too, just like we did the digital world.
Actually, this comments were very important, right? There are a lot of industries, and it's not because they don't want to move faster. It's just the compliance and the safety for the individuals, the governments, and various other stakeholders require certain amount. So while autonomous is a system that can actually accelerate a lot of this decision making, some of these are going to be impaired till the regulations come in right levels with technology. It's going to be a little laggard, and in some cases it's going to be safe for all the stakeholders till that point, till the regulations come to the same levels as technology.
One question I think there is, we've talked throughout the day on all the panels. I've heard people say, are you worried about losing jobs to autonomous systems? And the answer is always no. They get to work on more interesting projects, things later on. There's entire industries where I don't think that's the case. If your entire job is to look through the history, the last 200 years that this house has existed, to make sure nobody else has a claim on it, and I automate you out of a job, what's the higher level, more interesting thing that you get to do as a paper pusher?
That's exactly right. Yep.
It doesn't exist. In engineering, that's a whole different story, because there's all these places where we don't have enough staff, and we say, I can't work on that feature for you for another 2 years because I'm busy, tweaking auto scaling groups. I take that problem away. The engineer gets to go write code to do something different, make money for the company. I don't know how you do that in the physical world. So I think and some of the regulations exist because we got to give people jobs in the physical world.
Either that, or just keep and save your assets, right? If the houses can move fast as like a stock market related items within minutes, by the fourth transaction, you just don't know who owns that particular asset. Right. And going to what you were saying, if that's the biggest asset class, you need to put some boundaries around it. Same thing with payments, same thing with multiple different things.
Yeah. So my worry with that conversation was that it's at this very high level. I think when we talk about Sedai and the types of things that it can automate, it's at sort of this level, right? Like Sedai can't help with the problems you just spent 5 minutes talking about. So that's the litmus test.
Yeah, I would say Sedai is a component in the whole equation, right? So it's not that the Sedai is not doing its job. It's just that to revolutionize these type of industries with the autonomous systems, you need to have a lot more Sedais. Not just one Sedai is not going to help. So you need to build more of these kind of automation systems. Back to the point that you made is that you just don't want to build one big system, monolithic system. You need to build small components and then stitch them together to run autonomously. And that can very well be done for any industry, I would claim.
Yeah, actually, I would tend to agree with that, which is that I think what you're describing is what are the sets of capabilities you need to kind of for an entire business process. And that's going to kind of cover from like, hey, what is the the history of this particular property, what is the language in the contract, and is there anything unusual in this particular contract before I actually sign it, which is honestly something which I would do, because kind of going back to your point, I'm pretty darn certain I didn't read all 700 pages or whatever the darn document, because I'm pretty sure it actually took a half an hour to sign. And if there is any way to kind of say, hey, this is standard and there is nothing unusual, versus, hey, there's a special clause here, which is you're going to be signing off your firstborn child, I would actually like to know that, right? And I think that's the kind of thing which an AI system would be really good at, is identifying something which is really unusual, rather than me having to kind of saying, do I write this? And started being somebody who's like an engineer, as somebody else said, right? The first 10 pages, or maybe the first 7 pages, I tried to read everything. And then after that, it was like, okay, screw this. I'm just not going to be able to do that. But I think that's the whole set of the stack about what level of capabilities do we need for those things to become mainstream.
It comes down to standardization, and I think as many points in the decision tree along the way. Each time you make a standard, that standard becomes automatable. You complain about the contracts here in California for buying a house. In New York, you can't buy a house without having a lawyer on either side, negotiate the red lines. There's 0 standards. So that's, here at least there's forms. You look at it and it's pretty clear. Open source world, where you're at, licenses have become easier to think about and reason about. Why? Because it's no longer a random license that a lawyer at 3 different companies each wrote that may not be compatible with other one. We know GPL does this, Apache does this, BSD does that. And so I think at each point in our, in our stack, whether it's the cloud or the business or the economy, whatever it is, as we standardize, you can automate.
And I think this kind of gets back to the previous conversation or on the panels on what is the level of L0 through L5, which people brought up. I think that is actually where the standardization basically, or a framework for actually saying, hey, this can be automatable, this can actually be understood, and the exceptions identified and measured, and how the model works is going to be a key part of how we describe systems going forward.
At Talkdesk, we, sorry, I'm just trying to bring it home.
Actually, I had a note out to ask you about your adoption of autonomy.
So why didn't I take it that way, right? At Talkdesk, the way we do, Vikram, is if you can think of what we do today is slightly different, but where we want to go, the way we are thinking is, if you can think of a 3x3 matrix, y-axis being AI and x-axis being human, easy to hard on y-axis, easy to hard on the humans. If you look at that axis, the easy for AI, but the hardest for humans is probably the magic quadrant. Or everything along that x-axis is going to be your area for autonomous. Those are your low-hanging fruits, right? The moment you kind of go to the hard for humans, this is where a lot of volume work is to be done, whether it is, just because lack of human power, lack of time, lack of expertise, so on and so forth. A simple example is non-sufficient. Let me just pick up. Banks sending you a non-sufficient fund notice, $25 fine. The bank already knew, you don't have that money in that account, and a car loan is supposed to be in auto pay in next 2 days. They could have easily sent you a SMS saying that, hey, you're going to be out of funds. They can't physically do it today because the amount of human engagement that's needed to write complex queries, search multiple things, and then finally send out an out notice, right? Instead, and when you have hundreds and millions of accounts or hundreds and millions of customers, it's impossible. This is the areas where we can have autonomous things kind of come in very quickly and do things which are much harder for humans to do, but much more easier for AI to do. Okay, so that's the kind of philosophy we kind of use. And we don't do it just at the application level. We are also looking at it from an infrastructure level.
Are we supposed to end at 5:30? Okay, let's 5:34. Any last comments?
I'm glad to hear people index so much on observability because that's what I run at Lambda. So and just a general comment, I think getting rid of undifferentiated heavy lifting, which I talk about all the time, is perhaps one of the first steps towards getting to this world where we want things to be autonomous. If someone has to come in and sew a whole bunch of things together every single time you have to stand up a stack, that setup is the furthest away from being autonomous in general in any kind of setup. You can have any kind of architecture. When you have to go do that, then you're nowhere near being autonomous. So
So the one thing I was hoping we'd kind of actually have a very spirited discussion about is centralized or decentralized or federated. But we didn't get a chance to do that. But
Well, let's make one round real quick.
I think centralized is, one of the first things I would say for the first question you brought up. Lack of autonomous. Centralized is a architecture which will kind of lead to that kind of challenges, where you will not be able to make anything autonomous. That's just my comment.
So the way so again, I'm part of First American, and there's a lot of traditional industries who are probably structured the similar way. They build their systems maybe 10, 15, 30, 40 years ago. And the kind of the intelligence or the knowledge resides across multiple things, right? In order for you to make any change, any new capability, you have to interact with these kind of systems. And it becomes very hard to introduce any new thing. So looking at all of that, I think if there was a centralized system, right, which understands, and I'll take First American as an example, understands its business really well. That means it has consumed all the data, all the deeds, all the trust, all the mortgages that exist in the world, and it can do that. Then all you have to build is very lightweight systems which are targeted towards your internal employees, whether title examiners, escrow officers, or your customers. And they're just interacting and asking the right questions to this big central autonomous system, and it's giving the answers. That's the kind of the future stack that I think is going to emerge, at least in the traditional industries, if not in the tech industry.
But aren't you introducing a single point of failure in that case? Like every time you have to scale, not just in size, scale in functionality, scale in technology, you have to first go make sure that the central system or whatever structure that is, it understands what's going to happen. Otherwise, you sort of siloed a thing that probably exists, but nobody knows about.
So I'll use AWS in 2 different zones. That help?
I mean, I think the question is if you have to go change. I mean, so right now the challenge you have is everything's distributed across 100 systems, and you want to change some business logic after they go change 100 systems. On the other side of it, we've just spent the last decade trying to get away from these crazy monoliths where everything's in a big ball of code that we can't understand and can't deploy because it might break a bunch of decisions we're trying to make. So I don't think there's an answer of federated versus centralized. You have to make the right decision at the right place in your organization, but it's a spectrum. And we've just spent how many years getting to containers because I can put everything in one binary and put it out there and there's no changes. In the same way that we just spent the last 10 years going to microservices. I assure you, in 5 years, I'm going to see a talk on a panel here or a panel in our conference here about how shared libraries are amazing, and you only have to open up. You only have to upgrade up an SSL once with an apt-get command, right? Like the world just moves in these very clear, pendulum swings, and when the answer is usually somewhere in the middle. But we never find that middle.
But again, as you said, so it depends on what technology cycle you're in, right? So right now we live in the Gen AI and LLM world where I see a potential of this being the center of the universe, right? So now the pendulum is going to swing towards that. And once that ride is over, maybe the next thing comes and then the pendulum swings back again. But based on what I'm seeing is that it makes sense for me to just consolidate all the knowledge that I have of the enterprise into this system. And that will make things so efficient. And I'm talking at the application level, not at the microservices level, but applications wise. It just makes sense to take out the intelligence from different apps, put it in the center place, and then just create a thin experience layer. That's the kind of the thing that's going to happen. But again, you're right. The pendulum is going to swing back again some point in time.
Yeah, someone I was talking to earlier about these ideas said we should never put any configuration in code or forget about infrastructure as code. Don't put anything in there. Just let autonomous systems derive the configuration. So just write the business logic. Don't put how many replicas you want, how many servers you want, how many connections. None of that should be not only in your code, but also not in IAC. But it should all be derived based on load and other things.
That's what serverless does, though.
Yeah, but that's if you're using Lambda. I think he was talking about everything.
Yeah, I mean, the concept can be more broadly applied. Forget about the event-driven model. I mean, Fargate, for example, serverless, where you don't have to make the scale up, scale down decision.
Oh, scale up, scale down for services or pods or whatever is just one
Right.
One example of that. And he was saying everything,
Right.
anything like that. Yep.
I'm sure we can actually talk about that for the next half an hour.
Yeah. We need to wrap, right? Okay. Thank you. Thanks for participating so energetically.
Thank you.
Thank you. Thanks.